Tonight, we're going to take a journey that begins exactly where you are right now, lying still, breathing slowly, perhaps already feeling the edges of sleep beginning to soften the world around you. You feel motionless. You feel at rest. And in every way that your body can perceive, you are. But here is the thing most people never stop to realize. At this precise moment, as you close your eyes and let the quiet of the night settle over you, you are moving. Not slowly, not gently. You're hurtling through the darkness of space at speeds so incomprehensible, so brutally vast, that no vehicle ever built by human hands has come even close to matching them. You're a passenger on a journey you never chose, and you have been moving since the moment you were born. Think about that for just a second. Right now, the ground beneath you is spinning. The planet carrying you is racing around a star. That star is sweeping through an arm of a galaxy so wide it takes light itself 100,000 years just to cross it. And that galaxy, our galaxy, the Milky Way, is falling through the dark towards something enormous and mostly hidden. Something so massive it bends the paths of thousands of galaxies toward it like rivers pulled by gravity toward the sea. Layer upon layer upon layer of motion, each one stacked on top of the last, each one invisible to your senses, each one happening right now, tonight, as you lie here and breathe. By the end of tonight, you are going to understand exactly why the universe is the most restless place imaginable, and why the stillness you feel is one of the greatest illusions in all of nature. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. There is something quietly terrifying about this idea. Not the kind of terrifying that wakes you up in the night, but the kind that sits with you, slow and heavy, like the realization of something you always half knew but never dared to fully look at. We think of space as the place out there, the darkness beyond the atmosphere, the cold emptiness between the stars. But space is not out there. You're inside it. You have always been inside it. And tonight, together, we are going to feel the full weight of that truth, layer by layer, speed by speed, until the universe feels less like something distant and more like the ocean you have been swimming in your entire life without ever knowing the water was there. Now, let's begin. There is a moment, right at the edge of sleep, when the world goes completely quiet. The sounds of the day fade. The weight of your body settles into whatever surface is holding you. Your breathing slows, and the muscles you have been tensing since morning finally let go. In that moment, you feel something that every human being on this planet knows instinctively. You feel still. You feel like you have stopped. Like the universe has given you permission just for tonight to rest in one place. But I want you to sit with something gently before your mind drifts too far towards sleep. That feeling of stillness is not real. It is one of the most complete and convincing illusions that nature has ever produced. Because right now, as you lie here, as your eyelids grow heavy and your thoughts begin to soften at the edges, you are not still at all. You are moving. You have always been moving. And the speeds involved are so far beyond anything your body was built to perceive that your nervous system simply gave up trying to register them long ago. This is the central mystery I want to explore with you tonight. Not a mystery in the dark and frightening sense, though there is a quiet kind of vertigo that comes with it. More like the mystery of a magic trick you have watched your whole life without ever being shown how it works. The universe is in constant, layered, almost violent motion, and you are inside it. Not watching from a distance, not standing on the outside looking in. You are a passenger, right now, on a vessel moving at speeds that would leave every rocket ever launched by human civilization standing perfectly still by comparison. Here is the thing most people do not realize. Motion, at the scale of the cosmos, does not feel like anything. That is not a poetic statement. It is a precise one. When you are inside a car moving at a steady speed on a smooth road, you do not feel the motion. You only feel it when the car accelerates or brakes or hits a bump in the road. Your body is not a speedometer. It is a change detector. It notices when motion starts or stops. It notices turbulence. It notices direction shifts. But steady, uninterrupted movement, your nervous system is completely blind to it. And that is exactly the situation you're in right now. Lying here in the dark, the ride is perfectly smooth. and so you feel nothing at all. The ancient Greeks looked up at the sky and reached a perfectly reasonable conclusion. The Earth was the centre of everything. It was fixed, unmoving, solid beneath their feet. The stars and the sun and the moon all moved around it in great slow circles. This was not ignorance, it was honest observation. Because if you go outside tonight, right now, and lie down in a field and watch the sky for an hour, you will see exactly what they saw. The stars will drift. The moon will arc. The whole canopy of the night will turn slowly above you, as if the Earth itself is the still point around which everything else rotates. The illusion is that convincing. It fooled brilliant minds for thousands of years. It would fool you too if no one had ever told you otherwise. The first crack in that illusion came when Nicholas Copernicus, in the 16th century, proposed something that must have felt almost physically disorienting to the people who heard it. The Earth moves, not the sky, not the stars. The Earth itself is the thing in motion, sweeping around the sun in a great orbit, carrying every living thing on its surface along for the ride without asking permission and without giving warning. It took generations for that idea to fully settle into the human worldview, because it requires you to accept something deeply counterintuitive. The evidence of your own senses is wrong. The stillness you feel is a lie told to you by the limits of your own body. And Copernicus, extraordinary as he was, only cracked the surface. Because the motion he described, the orbit of the Earth around the Sun, is just the first layer, the shallowest one, the one closest to home. Beneath it, or rather surrounding it, are layer upon layer of additional motion, each one larger, each one faster in the grander sense, each one carrying you further and faster through the darkness of space than the one before it. Tonight, we are going to peel those layers back one by one. We're going to start where you are on this spinning rock, and we're going to keep pulling the camera back until the scale of your true motion through the universe becomes something you can actually feel, deep and slow, the way you feel something true rather than just understand it intellectually. I want you to imagine for a moment that you're standing at the edge of a river. The water looks calm from a distance. Smooth surface, quiet banks, no obvious turbulence. But when you look more carefully, you see that everything in that river is moving. The surface current. The deeper current beneath it pulling in a slightly different direction. The whole river itself curving slowly with the land it flows through, part of a watershed draining toward a sea miles away. Nothing in that river is still. Every drop of water is caught in multiple overlapping movements at once, each one nested inside a larger one. That is the situation you're in right now. Except the river is space, the currents are gravity and angular momentum, and the sea it is all draining toward is something so large and so strange that we only discovered it existed a few decades ago. What I love most about this idea, and what I hope stays with you tonight long after the words have faded and you have drifted into sleep, is this. Your stillness is not a failure of perception. It is a kind of gift. Your body was built for this planet, for this scale, for the small, beautiful distances of a human life. It was not built to feel the rotation of the Earth or the sweep of our solar orbit, or the long, slow plunge of our galaxy through the dark. Those things happen at scales your senses were never meant to track, but your mind can track them. And tonight, that is exactly what we are going to do. We are going to take everything your body cannot feel, and we are going to feel it anyway, together, slowly, one layer at a time. The illusion of stillness is about to dissolve, and what lies beneath it is one of the most astonishing things in all of science. The Earth rotates once every 24 hours. That is the simple version of the fact, the one you learned as a child, the one that explains why the sun rises in the east and sets in the west, why we have day and night, why the stars appear to wheel overhead as the hours pass. But the number hiding inside that simple fact is not simple at all. If you are lying somewhere near the equator tonight, the surface of the Earth beneath you is moving at roughly 1,000 miles per hour due to that rotation. 1,000 miles per hour. To put that in perspective, the fastest passenger jet ever built, the Concorde, flew at about 1,350 miles per hour. That means right now, lying perfectly still in the dark, you're moving at a speed close to supersonic flight, and you feel absolutely nothing. The speed is not the same everywhere on the planet. This is one of the more quietly strange facts about rotation. Because the Earth is a sphere, different parts of its surface have to travel different distances to complete one full rotation in the same 24 hours. The equator is the widest part of the sphere, so it has the most distance to cover. It moves at around 1,000 miles per hour. But as you move toward the poles, the circle you are tracing gets smaller and smaller. Someone standing at the North Pole or the South Pole is not really moving laterally at all. They are just spinning in place very slowly like the tip of a top. A person standing in Madrid tonight is moving at roughly 890 miles per hour. Someone in London, closer to the pole, is moving at around 650. The rotation is the same. The speed of the surface beneath your feet depends entirely on where you happen to be standing on the sphere. So why can you not feel it? That is the question that always comes up, and it deserves a real answer rather than a quick dismissal. The reason is that the rotation of the Earth is extraordinarily smooth and extraordinarily consistent. There are no bumps, there is no turbulence. The speed does not change from second to second in any way your body could detect. Remember what we talked about earlier, how your nervous system is a change detector rather than a speedometer. It notices acceleration, it notices sudden shifts in direction. But a perfectly steady rotation that has been going on for 4.5 billion years without variation, your body has absolutely no mechanism for sensing that. It is like being inside an enormous ship on a perfectly calm sea. If the ship never rocks, never accelerates, never changes direction, you could sit inside it and feel completely motionless even as it crosses an ocean. But the rotation does leave fingerprints, subtle ones, invisible in daily life, but measurable and real. The most famous is the Coriolis effect. Because the Earth is spinning, anything moving freely across its surface, whether air, water, or a long-range missile, gets deflected slightly to one side. In the northern hemisphere, freely moving objects curve to the right. In the southern hemisphere, they curve to the left. This is why large weather systems, hurricanes and typhoons and massive storm cells rotate in opposite directions depending on which side of the equator they form. In the northern hemisphere, hurricanes spin counterclockwise. In the southern hemisphere, they spin clockwise. The spin of the entire planet is embedded in the spin of every major storm. Every time you see a satellite image of a hurricane from space, you're looking at the fingerprint of the Earth's rotation made visible in swirling clouds and wind. There is another fingerprint that is even more personal, the fact that you weigh very slightly less at the equator than you do at the poles. The spin of the Earth creates a tiny outward force, the same kind of force you feel when you spin a bucket of water over your head and the water stays in the bucket. At the equator, where the spin is fastest, that outward force is greatest, and it very slightly counteracts the pull of gravity. The difference is small, only about 0.5% of your total body weight, but it is real and it is measurable. Your body is being very gently flung outward by the rotation of the planet right now. Gravity is winning that contest by an enormous margin, which is why you stay on the ground. But the contest is happening. The spin is real. Now here is the thing I want you to sit with for a moment. The Earth has been rotating at roughly this speed for about 4.5 billion years. That is 4,500 million years of continuous spinning, without stopping, without slowing down in any meaningful way, without a single day off. Every human being who has ever lived, every civilization that has ever risen and fallen, every battle, every love story, every moment of grief or joy or wonder that has ever occurred on this planet, has happened on a surface moving at close to 1,000 miles per hour. The pharaohs of ancient Egypt were moving at 1,000 miles per hour. The first humans to walk out of Africa were moving at 1,000 miles per hour. You, right now, tonight, are moving at 1,000 miles per hour. None of them felt it, neither do you. And that shared blindness, that universal human experience of stillness that is actually speed, is one of the most quietly poetic things I know. But here is what I really want you to hold on to as we move forward, because this first layer of motion, the rotation, is in many ways the gentlest one. It is the most local, the most familiar, the one closest to home. The speed is astonishing by human standards. 1,000 miles per hour is faster than almost anything we have ever built. But in the context of what comes next, in the context of the layers of motion stacked above and beyond this one, 1,000 miles per hour is almost quaint, almost tender. It is the first step of a journey that is going to take us much, much further into the dark. So let the ground spin beneath you. Let it carry you as it always has, quiet and steady, and without asking anything of you. Because we are just getting started. So we have established the first layer, the spin, the 1,000 miles per hour that carries you through day and night without your body registering a single tremor of it. That is remarkable on its own. That is already a speed that would feel violent and impossible if you could somehow step outside the system and watch yourself from a distance. But I want you to take a slow breath now, because we are about to pull the camera back. We are about to add the second layer, and this one is not just faster than the first. It is not twice as fast, or 5 times as fast. It is roughly 67 times faster. While the Earth is spinning you at 1,000 miles per hour, it is simultaneously carrying you around the Sun at approximately 67,000 miles per hour. That number deserves a moment of silence. 67,000 miles per hour. Every hour of every day of your life, you have been travelling that distance through space, and you have never once felt it. To make that speed feel real, let me give you something to hold on to. The distance from New York to Los Angeles is roughly 2,800 miles. At 67,000 miles per hour, you would cover that distance in about 2.5 minutes. The entire width of the continental United States, gone in the time it takes to pour a glass of water. Or think of it this way, the Moon is roughly 239,000 miles away from Earth. At our orbital speed, we would reach the Moon in a little over 3.5 hours. Not days, not weeks, hours. The speed at which you're moving around the Sun right now is so immense that even the Moon, that distant silver companion we have been watching from this planet for our entire existence as a species, would be a short afternoon trip away. Now here is the number that I find even more staggering than the speed itself. Every single year, the Earth traces a complete orbit around the Sun, one full circle, and the circumference of that circle, the total distance travelled in a single year, is approximately 584 million miles. 584 million miles in 1 year. That is the distance you travel just by being alive on this planet for 12 months. You do not have to go anywhere. You do not have to get on a plane or drive a car or take a single step. Simply by existing on the surface of the Earth, you cover 584 million miles every year. In your lifetime, assuming an average human lifespan, you will have travelled somewhere in the region of 45 billion miles through space just in your orbit around the Sun alone. Before we even add the other layers, here is the thing most people do not realise about that orbit. It means you have never been in the same place in space twice. Not once. Not ever. The Earth comes back to the same position relative to the Sun every year. Yes, that is what a year is. That is what a birthday marks. But the Sun itself is moving, as we will explore soon, and so the point in space where the Earth was on the day you were born is a point that no human being, no particle of matter that has ever been part of this planet, will ever visit again. Every birthday is not a return. It is a new point in a spiral. You are always moving forward. You have never gone back. The universe does not allow it. And yet, once again, you feel nothing. The orbital motion is just as invisible to your senses as the rotation. Perfectly smooth, perfectly consistent. No acceleration your nervous system can detect. But this motion does leave fingerprints too, and one of them is something you have experienced your entire life without perhaps connecting it to the fact that you are hurtling through space at 67,000 miles per hour. That fingerprint is the seasons. As the Earth orbits the Sun, its axis, that imaginary line running from the North Pole to the South Pole, is tilted at an angle of about 23.5 degrees relative to the plane of the orbit. It does not change. It always points in roughly the same direction in space, toward the star Polaris in the northern sky. But as the Earth moves around the Sun, that fixed tilt means that sometimes the northern hemisphere is leaning toward the Sun and sometimes it is leaning away. When it leans toward the Sun, the northern hemisphere gets longer days and more direct sunlight. Summer. When it leans away, shorter days and weaker sunlight. Winter. The seasons are not caused by the Earth getting closer to or further from the Sun. They are caused by the tilt of a spinning rock moving at 67,000 miles per hour. The warmth of every summer you have ever felt was the fingerprint of an orbit you could not perceive. There is another fingerprint, quieter and stranger. The way starlight shifts depending on the time of year. When astronomers look at nearby stars, they can measure a tiny apparent shift in the star's position against the background of much more distant stars. In January, a nearby star appears to be in a slightly different position than it does in July. Not because the star moved, because we moved. Because the Earth has swept halfway around its orbit between January and July, giving us a slightly different angle on the star, like how a nearby tree appears to shift position against a distant mountain when you take a few steps to the side. This effect is called stellar parallax, and it was the first direct observational proof that the Earth really does orbit the Sun. The stars themselves confirmed our motion. The universe left us evidence in the light. I want to close this layer with something that I find genuinely moving, in the quiet way that true things sometimes are. Right now, while you lie here in the dark, the Earth is carrying you through space at 67,000 miles per hour. It has been doing this for 4.5 billion years, long before there was any life on this planet, long before there were oceans or continents or atmosphere. The bare rock of the early Earth, molten and silent and already ancient, was orbiting the Sun at this same speed. And when the first single-celled organisms appeared in the shallow seas, they were moving at 67,000 miles per hour. When the first fish crawled onto land, 67,000 miles per hour. When the first human beings looked up at the stars and wondered what they were, 67,000 miles per hour. The orbit has never paused. The speed has never changed in any way that matters. And tonight, it is carrying you too. Quietly, faithfully, without asking anything of you at all. Sleep if you need to. The orbit will continue without you having to think about it for even a single second. The Milky Way is a galaxy. You know that word, galaxy, the way you know the word ocean. You know it refers to something enormous and deep and full of things beyond counting. But let me try to give you the actual scale of it, because the scale is what makes the motion meaningful. The Milky Way contains somewhere between 100 billion and 400 billion stars. Not millions, billions. And those stars are not crowded together like grains of sand in a jar. They are spread across a disk of space roughly 100,000 light-years wide. A light-year is the distance light travels in a single year, moving at 670 million miles per hour. 100,000 light-years. If you built a scale model of the Milky Way where the entire distance from Earth to the Moon represented just one light-year, the galaxy would be so wide it would stretch from Earth to the Sun and back again nearly 200 times. It is an almost meaningless number until you sit with it long enough for the weight of it to settle. Inside this galaxy, our Sun is not at the centre. We are out in the suburbs, roughly 26,000 light-years from the galactic core, sitting in a relatively quiet region of one of the spiral arms. And just as the Earth orbits the Sun orbits the centre of the Milky Way. It traces a vast, slow, sweeping path around the galactic core, pulled by the combined gravity of hundreds of billions of stars and an enormous concentration of mass at the very centre that we will talk about in the next chapter. That orbit takes somewhere between 225 million and 250 million years to complete. Astronomers call this period a cosmic year or a galactic year. One full trip around the Milky Way, one cosmic year. And in the entire history of complex life on Earth, from the first animals in the Cambrian period to this exact moment tonight, the Sun has completed less than 2 full laps. But the speed, let us talk about the speed, because that is what makes this layer of motion so staggering. To complete that enormous orbit in a cosmic year, the Sun, and everything gravitationally bound to it, including the Earth, including you, must be moving at approximately 514,000 miles per hour. 514,000 miles per hour. We went from 1,000 miles per hour at the spin of the Earth to 67,000 in the orbit around the Sun, and now we have leaped to 514,000, more than 500,000 miles per hour. At that speed, you would cross the entire continental United States in under 20 seconds. You would travel from the Earth to the Moon in less than 30 minutes. The distance that light takes 8 minutes to cover, from the Sun to the Earth, you would cross in just over 10 hours. This is the speed at which you're moving through the Milky Way right now, carried by a star that has never once asked you to hold on. Here is something I want you to picture, because I think it is one of the most beautiful and disorienting images in all of astronomy. The path the solar system traces through the Milky Way is not a flat, simple circle. It is more like a helix, a corkscrew shape, because as we orbit the galactic centre, we also bob up and down through the plane of the galaxy. The Milky Way is a disk, and the solar system oscillates gently above and below the midplane of that disk as it moves. Right now, we're slightly above the midplane and moving toward it. In about 30 million years, we will pass through and begin rising above it again. This gentle bobbing motion, up and down through the galactic disk over tens of millions of years, may even influence events on Earth. When we pass through the denser regions near the midplane, the increased concentration of dust, gas, and gravitational disturbances may nudge comets from the outer edges of our solar system inward, increasing the chances of impacts. The rhythm of the galaxy may be written, very faintly, in the fossil record of our own planet. Now let me give you a number that I think is the most quietly astonishing thing we have discussed so far. The Sun is about 4.5 billion years old. In that time, moving at 514,000 miles per hour around a galaxy 100,000 light-years wide, it has completed approximately 20 full orbits of the Milky Way. 20. In 4.5 billion years of continuous motion at 500,000 miles per hour, the Sun has gone around the galaxy 20 times. That is how immense the galaxy is. That is how long even a cosmic year truly lasts. 20 laps in the entire lifetime of our star. When the Sun was born, the galaxy already existed in something close to its current form. When the Sun dies, in another 5 billion years or so, it will have completed perhaps another 20 laps, 40 total, in a 10 billion year lifetime. The galaxy is not just large. It is large in a way that makes time itself seem like a small and local thing. And yet, just as with the rotation and the orbit, you feel none of this. Not a tremor, not a whisper. The solar system moves through the galaxy with the same smooth, uninterrupted consistency that the Earth moves around the Sun. No jolts, no turbulence in any form your body could register. The stars around us are so far apart, the interstellar medium so thin, that our passage through the galaxy is as silent and unfelt as a breath. You're riding a star that is riding a galaxy, moving at 514,000 miles per hour through the dark, and the only sound in the room is whatever quiet you have managed to find tonight. That silence is not emptiness. It is the most complete and ancient motion imaginable, dressed up as stillness, carrying you forward through space without ever needing you to notice. There is a kind of number that stops being a number at a certain point. It becomes something else, not a quantity you can hold in your mind and manipulate the way you do with ordinary figures, but more like a doorway that opens onto a darkness so deep that your eyes cannot adjust no matter how long you stand there looking. 225 million years is that kind of number. That is the length of one galactic year. One full orbit of the Sun around the centre of the Milky Way. 225 million years of continuous motion at 514,000 miles per hour. And at the end of it, you're back where you started relative to the galactic core. Not relative to the rest of the universe, as we will discover, because the galaxy itself is moving. But relative to the great slow wheel of the Milky Way, one cosmic year is 225 million of our years, and I want to spend some time with that number tonight, because I think it contains some of the most humbling perspective available to a human mind. Let us anchor it in something biological, something from the history of life on this planet, because that is the only timescale large enough to make the galactic year feel real. 225 million years ago, the Earth was in the middle of what geologists call the Triassic period. The Great Permian extinction had only recently ended, an event so catastrophic it wiped out an estimated 96% of all marine species and 70% of all land vertebrates. The planet was still recovering. The continents were joined together in a single vast landmass called Pangaea, a supercontinent stretching from pole to pole surrounded by one enormous global ocean. The first dinosaurs were just beginning to appear, small and uncertain, feeling their way into a world that had been almost emptied. Mammals had not yet emerged in any meaningful form. Flowers did not exist. The familiar world we know, its birds, its flowering plants, its grasses and forests and coral reefs, none of it had been invented yet. That is where we were, in the history of life on Earth, exactly one cosmic year ago. The Sun has completed one single lap of the galaxy since the first dinosaurs were finding their footing on a continent that no longer exists. Now go back 2 cosmic years, 450 million years ago. We are in the Ordovician period. The oceans are full of strange armoured creatures, early fish, nautiloids, trilobites carpeting the seafloor in their millions. Plants have only just begun the slow, extraordinary project of colonizing land. Insects do not exist yet. Vertebrates have not yet made it out of the water. The land is bare rock and primitive moss, alien and silent in a way that would be unrecognizable to any human eye. 2 laps of the galaxy ago, that was Earth. 2 laps in 4.5 billion years of the Sun's existence. Think about that geometry. The entire story of vertebrate life on land, from the first fish to drag itself out of the shallows to every human civilization that has ever risen and fallen, fits inside a single galactic year. The whole of recorded human history, every empire, every invention, every war, every generation of every family that has ever lived, represents less than 100,000th of a single cosmic lap. Here is the thing most people do not realize about the galactic year and what it tells us about our place in time. The Sun is currently estimated to be about 4.5 billion years old. Divided by a galactic year of 225 million years, that gives us approximately 20 completed orbits since the Sun's birth. 20 cosmic years. The Sun is, in galactic terms, roughly 20 years old if you compressed the entire lifespan of the Sun into a single human lifetime of 80 years. Each galactic year would represent 4 human years. The Sun would currently be in its early 20s. The Earth formed when the Sun was about 5 galactic years old. Complex multicellular life appeared around galactic year 16. Dinosaurs rose and fell in a span of less than 1 cosmic year. Humans appeared in the last few weeks of the Sun's current galactic age. All of human civilization fits inside the last few hours. Tonight, lying here, you exist in the final seconds of the Sun's 20th cosmic lap. That is where we are in the story. The galactic year also gives us a haunting way to think about the future. The Sun is expected to live for another 5 billion years or so before it exhausts its hydrogen fuel and begins to swell into a red giant. 5 billion years divided by 225 million years per orbit gives us roughly 22 more cosmic years remaining in the Sun's life. 20 more laps around the Milky Way. In that time, the continents will have rearranged themselves beyond recognition. The Atlantic Ocean will have closed and opened again. Mountain ranges that do not yet exist will rise and erode to plains. Whatever life exists on Earth in 20 cosmic years, if anything does, will be as different from us as we are from the Triassic bacteria that lived when the first dinosaurs walked a supercontinent. The galactic year is not just a measurement, it is a window onto deep time, the vast, slow river of geological and biological change that our brief human lives float on without ever feeling the current. I want to give you one more image before we move on, because I think it captures the galactic year better than any number can. Imagine you are watching a time-lapse of the Milky Way from far above, from some impossible vantage point outside the galaxy entirely. You watch the great spiral arms turning, slowly, the way cream turns in a stirred cup of coffee, slow and beautiful and inevitable. In this time-lapse, 1 second of your watching equals 1 million years of galactic time. At that rate, a human lifetime of 80 years would be visible for less than a millionth of a single frame. A galactic year would pass in about 3 minutes and 45 seconds of your watching. In a single hour of observation, the galaxy would complete roughly 16 full rotations. The Sun would be born, live its entire life, and die, all in about 2 hours and 40 minutes of your viewing time. The entire age of the universe, from the Big Bang to today, would take just over 3.5 hours to watch. And in all of that slow wheeling, in all of those rotations, the fraction of time represented by everything you have ever known or loved or lost would be invisible. Too small to see. Gone before a single frame could capture it. And yet here you are, awake to it, aware of it, moving through it at 514,000 miles per hour, on a rock that has been making this journey for 20 laps already, carrying everything that has ever mattered to any human being who has ever lived. Every orbit needs a center. Every great circular journey, no matter how vast, traces itself around something. The Earth orbits the Sun because the Sun's gravity reaches out across 93 million miles of empty space and holds us in its pull, the way a stone on a string is held by the hand swinging it. But what holds the Sun? What is the anchor point of our 225 million year journey around the Milky Way? What sits at the center of the great spiral we are slowly, silently circumnavigating right now, tonight, as you lie here and breathe? The answer is something that took decades of careful observation to confirm, something so extreme and so strange that even the physicists who predicted its existence were not sure the universe would actually permit it. At the centre of our galaxy, roughly 26,000 light-years from where you are lying right now, there is a black hole, and it is not a small one. It is a supermassive black hole, a thing of almost incomprehensible mass and gravity, and it has been sitting at the heart of the Milky Way since the galaxy itself was young. Its name is Sagittarius A star. Astronomers write it as Sagittarius A with an asterisk, a notation that refers to a specific type of radio emission, but the name itself matters less than what it describes. Sagittarius A star has a mass of approximately 4 million times the mass of our Sun. 4 million solar masses compressed into a region of space smaller than the distance between the Earth and the Sun. To put that another way, if you took 4 million stars like our Sun and collapsed them all together into a single point, you would begin to approach the density of what sits at the centre of our galaxy. The gravity produced by that kind of mass at that kind of concentration is so extreme that nothing, not matter, not radiation, not light itself, can escape once it crosses a certain boundary. That boundary is called the event horizon. Everything that falls past it is gone from the observable universe forever. No information escapes, no signal, no evidence of what happened inside. The event horizon of Sagittarius A star is a circle roughly 24 million miles across. 24 million miles of absolute irreversible darkness at the centre of the galaxy we are orbiting right now. For most of human history, we did not know it was there. The centre of the Milky Way is hidden from our view by enormous clouds of gas and dust that block visible light completely. You cannot see the galactic centre on a clear night the way you can see nearby stars or even distant galaxies. It is obscured, veiled, tucked behind curtains of interstellar material so thick that visible light cannot penetrate them. But radio waves and infrared radiation can. And when astronomers began developing instruments sensitive enough to detect those wavelengths in the second half of the 20th century, they started seeing something extraordinary. Stars near the galactic centre were moving in ways that made no sense unless there was an enormous concentration of invisible mass right at the middle. Not just large, not just heavy, absurdly, almost impossibly massive for the volume of space it occupied. The confirmation came slowly over decades, through one of the most patient and meticulous observational campaigns in the history of astronomy. Two teams of scientists, one led by Reinhard Genzel in Germany and one led by Andrea Ghez in the United States, spent more than 25 years tracking individual stars near the galactic centre. They watched these stars move. Year after year they mapped their positions, measured their velocities, traced their paths through space, and what they found was extraordinary. These stars were moving in tight, fast elliptical orbits around a single invisible point. One star, known simply as S2, completes a full orbit around Sagittarius A star in just 16 years. At the closest point of its orbit, S2 moves at nearly 3% of the speed of light. 3% of the speed of light for a star. The only thing that could produce that kind of orbital speed at that kind of distance is a mass of 4 million suns packed into a space far smaller than our own solar system. In 2020, Reinhard Genzel and Andrea Ghez shared the Nobel Prize in Physics for this work. The dark heart of our galaxy had been confirmed beyond any reasonable doubt. Now here is what I want you to sit with quietly, in the way that only the dark and the late hour allow. Right now, tonight, you are orbiting that thing. Not closely, not dangerously. 26,000 light-years is a safe and comfortable distance, and the gravitational influence of Sagittarius A star at this range is just one component of the much broader galactic gravitational field that keeps the Sun on its orbital path. You're in no danger. But the geometry is real. The centre of your galactic orbit, the point around which your 514,000 mile per hour journey is currently curving, is a black hole 4 million times more massive than the Sun. Every lap you take, every 225 million years, you're tracing a vast ellipse around something that devours light. There is something in that image, something between awe and vertigo, that I find impossible to fully resolve into either comfort or fear. It simply sits there, demanding to be felt. Black holes, particularly ones this massive, carry a kind of cultural weight that can make them feel mythological rather than physical, like dragons, like something invented to represent danger or the void. But Sagittarius A star is not a myth. It is a physical object with a measurable mass and a specific location in space. In 2019, the Event Horizon Telescope collaboration produced the first direct image of a black hole, capturing the shadow of the supermassive black hole at the centre of a galaxy called M87 55 million light-years away. Then in 2022, they turned the same network of radio telescopes toward our own galactic centre and produced the first actual image of Sagittarius A star itself. A glowing ring of superheated gas, blurred and shimmering because the black hole's gravity bends light around it in all directions, with a dark central shadow where nothing escapes. For the first time in human history, we had a photograph of the thing our galaxy orbits, the thing your cosmic journey curves around. It looked like an ember in the dark, ancient and calm and absolute. I think there is something quietly profound about the fact that we orbit a black hole and have only just learned to see it. For the entire history of our species, for every generation of human beings who looked up at the night sky and wondered what was out there, the centre of our galaxy was invisible, hidden, a mystery wrapped in dust and distance. We built our myths and our sciences and our religions without knowing that the heart of the spiral we live in was a point of infinite density and absolute darkness. And then, in the span of a single human lifetime, we developed the instruments to pierce the veil, to track the stars that orbit the void, to photograph the shadow of something that eats light. We are a young species on a middle-aged star in the outer suburbs of a spiral galaxy that rotates around a 4 million solar mass black hole, and somehow, against all the odds of scale and time, we figured that out. Tonight, as you drift towards sleep, that knowledge is yours. The dark heart at the centre of everything is 26,000 light-years away, and it has been holding your orbit for as long as the sun has existed, 1.3 million miles per hour. Let that settle for a moment before we go any further. We went from 1,000 miles per hour at the Earth's rotation, to 67,000 in the solar orbit, to 514,000 around the galactic centre. And now, adding the motion of the Milky Way itself through the larger cosmic structure, we arrive at 1.3 million miles per hour as the speed of our galaxy's directed motion through space. At that speed, you would travel from the Earth to the Moon in about 11 minutes. You would cross the distance from Earth to the Sun in roughly 4.5 hours. In a single day, you would cover 31 million miles. This is the speed at which your galaxy is moving right now, carrying you and every other person alive tonight, and every star you have ever seen in the night sky, all of it hurtling together in the same direction through the dark. Now comes the part that I find genuinely unsettling, in that slow, heavy way that true things sometimes are. The Milky Way is not drifting randomly. It is not simply coasting through space the way a ship drifts on a currentless sea. It is being pulled. There is something out there, something at an enormous distance in a specific direction, that is exerting a gravitational influence so powerful it is drawing not just our galaxy, but hundreds of other galaxies toward it, like tributaries drawn toward a drain. This thing, this gravitational anomaly that has been reshaping the large-scale motion of galaxies across hundreds of millions of light-years, has a name. Astronomers call it the Great Attractor, and when they first discovered its influence in the 1980s, it raised an immediate and deeply unsettling question. What is it? Because they could not see it. They could measure its gravitational effects with precision. They could map the flow of galaxies toward it across vast distances. But the thing itself was hidden, and the reason it was hidden is one of the stranger ironies in all of observational astronomy. The Great Attractor lies in a direction of the sky that happens to align almost perfectly with the plane of the Milky Way itself. Remember those clouds of dust and gas that obscure the galactic centre in visible light, the same clouds that hid Sagittarius A star from us for so long. Those clouds are spread along the entire plane of the galaxy, forming what astronomers call the zone of avoidance, a band across the sky where the density of our own galaxy's material blocks our view of everything behind it. And the Great Attractor sits almost directly behind the thickest part of that zone. We are being pulled towards something that our own galaxy is hiding from us. We are falling in a direction we cannot clearly see. If that does not produce a faint low hum of existential unease somewhere in the back of your mind tonight, I'm not sure what would. What we have been able to determine, using radio waves and X-rays and infrared observations that can partially penetrate the zone of avoidance, is that the Great Attractor is associated with an enormous concentration of galaxies centered around a region of space roughly 250 million light-years away. The heart of this concentration appears to be a massive galaxy cluster called the Norma Cluster, also designated Abell 3627. This cluster sits within a larger structure called the Great Attractor region, and the combined mass of all the galaxies, gas, dark matter, and other material in that region is genuinely staggering, perhaps tens of thousands of times the mass of the Milky Way. The gravitational reach of that much mass at that distance is long and patient and absolutely real. It has been reshaping the motion of our local group of galaxies for billions of years, and it will continue to do so for billions more. But here is where the story becomes even stranger, and I want you to stay with me here because it opens onto something we will explore more deeply soon. The Great Attractor, vast as it is, may not be the final destination. More recent observations have suggested that the Great Attractor itself, along with the broader Laniakea supercluster we are part of, may be moving toward an even larger concentration of mass called the Shapley supercluster, located roughly 650 million light-years away. Layer upon layer of gravitational influence, each one nested inside a larger one, each one pulling our galaxy along a path through intergalactic space that we're only beginning to map. We are not falling toward one thing. We may be falling toward a sequence of things, each one larger and more distant than the last, in a cosmic drainage pattern that stretches across scales we have only recently become capable of measuring. I want to close this chapter with an image that I think captures something essential about this layer of motion. Imagine you are standing on a beach, watching the tide come in. Each individual wave moves toward the shore, but the overall motion of the water, the tide itself, is driven by something much larger and much more distant. The moon pulling the whole ocean from 250,000 miles away. You cannot see the moon pulling the water, you cannot feel the tidal force with your body, but the water moves because of it, relentlessly and without exception, regardless of what the individual waves are doing on the surface. That is something like the situation we are in tonight. The individual motions, the spin of the Earth, the orbit around the Sun, the sweep around the galactic core, those are the waves, but beneath all of them, the whole ocean is moving. The Milky Way is the tide being drawn across intergalactic space towards something enormous and mostly hidden at 1.3 million miles per hour, and it has been moving this way for longer than the Earth has existed. You are on the wave, but you are also in the tide, and the tide has been running for a very long time. There are discoveries in science that arrive quietly, without fanfare, slipping into the literature almost unnoticed, and then slowly, over years and decades, reveal themselves to be among the most profound and disorienting things we have ever learned about the universe. The discovery of the Great Attractor was one of those. It did not make headlines the way a moon landing does, or a first photograph of a black hole. It emerged gradually from a strange pattern in data, a pattern that should not have been there, a pattern that took years to interpret and even longer to accept. And what it revealed, when the interpretation finally settled into place, was something that changes the way you think about where you are and where you're going. There is a structure in the universe so massive, so gravitationally dominant over such an enormous volume of space, that it is pulling hundreds of galaxies, including ours, toward it at speeds of over 1 million miles per hour, and for decades after its discovery, we could barely see it at all. The story begins in the 1980s, with a group of astronomers known informally as the Seven Samurai. This team, led by researchers including Sandra Faber and Donald Lynden Bell, was studying the motions of elliptical galaxies across a large region of the sky. They were trying to understand whether galaxies moved in the way that simple cosmological models predicted, following the general expansion of the universe, drifting apart from one another as space itself stretched. What they found instead was deeply puzzling. Galaxies across an enormous swath of the sky, including our own Milky Way and the nearby Andromeda Galaxy, and hundreds of others spread across hundreds of millions of light years, were all moving in the same direction, all flowing toward the same point in the sky, all being pulled toward a single region of space, with a gravitational force far beyond what any visible structure in that area could account for. Something was there. Something enormous. something that was not showing up clearly in their telescopes. They named it the Great Attractor, and the name has stuck, because it describes the situation with an almost unsettling precision. The mass required to produce the observed gravitational flow toward the Great Attractor region is extraordinary. Estimates have varied over the years as better data has accumulated, but the consensus is that the total mass concentrated in and around that region, including all the galaxies, all the gas, and the invisible dark matter that binds large-scale structures together, amounts to something in the range of 10,000 trillion times the mass of the Sun. That is not a typo. 10,000 trillion solar masses. For comparison, the entire Milky Way, with all its hundreds of billions of stars, has a total mass estimated at around 1 trillion solar masses. The Great Attractor region contains the gravitational equivalent of 10,000 Milky Ways. When you try to hold that number in your mind, it does not stay as a number. It becomes a feeling, heavy and dark and immense. The specific heart of the Great Attractor appears to be centered on or near the Norma cluster, a dense concentration of galaxies about 220 million light-years away in the direction of the constellation Norma in the southern sky. The Norma cluster itself contains hundreds of galaxies packed into a relatively small region of space, a gravitational knot of staggering density at the core of a much larger supercluster scale overdensity. But pinning down exactly where the centre of attraction lies has been one of the great observational challenges of the past half-century, precisely because so much of the relevant sky is hidden behind the disk of our own galaxy. Radio surveys, X-ray observations and near-infrared studies have all contributed to building up a picture, slowly and painstakingly, of what lies in the zone of avoidance. What has emerged is a complex and layered structure, a region of the universe that is genuinely overdense in galaxies compared to the cosmic average, a gravitational attractor on the largest scales we can currently map. Here is something I want you to consider for a moment, because it deepens the strangeness of our situation in a way I find almost vertiginous. The Milky Way is currently moving toward the Great Attractor at roughly 1.3 million miles per hour. At that speed, we might expect to eventually arrive, to close the distance and fall into whatever structure is pulling us. But we will almost certainly never get there, at least not in any meaningful sense. Because the universe is expanding, space itself is stretching in all directions, and the rate of that expansion increases with distance. The Great Attractor is far enough away that the expansion of space between us and it is carrying it away from us at a rate that competes with our gravitational infall. We are being pulled towards something that the expanding universe is simultaneously carrying away from us. We are perpetually falling toward a destination we may never reach, like walking up an escalator that is moving down just fast enough to keep the floor always the same distance below you. And then there is the Shapley supercluster. As observational techniques improved in the 1990s and 2000s, astronomers began to realize that even the Great Attractor itself appears to be embedded in a larger gravitational flow pointing towards something even more distant. The Shapley supercluster, located roughly 650 million light-years away, is one of the most massive known concentrations of matter in the observable universe. It contains dozens of galaxy clusters and thousands of individual galaxies, and its gravitational influence appears to extend across the enormous distances separating it from our own cosmic neighbourhood. Some researchers have suggested that the Shapley supercluster may be the ultimate driver of the large-scale flow that includes both our local motion and the Great Attractor itself, a gravitational mountain so high that even the Great Attractor is rolling down its slopes. We may be falling toward a Great Attractor that is itself falling toward something larger still. I want to close this chapter by returning to something simple and close and real, because I think the immensity of these structures can become numbing if we stay too far from the human scale for too long. Tonight, lying here, you're inside one of the most complex and beautiful structures in the known universe. You're part of the Laniakea supercluster, a vast cosmic web of galaxies stretching across 500 million light-years, all of it flowing, however slowly, however imperceptibly, in the direction of the Great Attractor. Laniakea is a Hawaiian word meaning immeasurable heaven. It was chosen by the astronomers who first mapped this supercluster in 2014, who decided that the scale of what they had found deserved a name that honoured both its immensity and its beauty. You live in the immeasurable heaven. You're a passenger in the largest coherent structure humanity has ever mapped, and it is falling, quietly and irresistibly, towards something we can feel but still cannot fully see. We have been building something together across this entire journey, layer by careful layer, the way a river builds a canyon, slowly and without hurry, each pass deepening what was already there. We started with the spin of the Earth, 1,000 miles per hour, invisible beneath your feet tonight as you lie here in the dark. We added the orbit around the Sun, 67,000 miles per hour, sweeping you through 584 million miles of space every single year. We added the solar system's great arc around the galactic core, 514,000 miles per hour, 20 laps completed in the Sun's entire lifetime. And then we added the motion of the Milky Way itself, falling toward the Great Attractor through intergalactic space at 1.3 million miles per hour, each layer stacked on the previous one, each one carrying you further and faster than you could feel or perceive. Tonight, in this chapter, I want to add all of those layers together and let the total land. I want you to feel, as fully as your resting, breathing, almost sleeping mind can manage, the true speed at which you are moving through the universe right now. The calculation is not perfectly simple, because these motions do not all point in the same direction. They are vectors, quantities with both magnitude and direction, and adding them requires accounting for the angles between them. The spin of the Earth points perpendicular to the Earth's axis. The orbital motion around the Sun points along the plane of the solar system. The galactic orbit sweeps in a different plane still, and the motion toward the Great Attractor points in yet another direction entirely. When astronomers combine all of these motions carefully, accounting for their directions as well as their speeds, the total velocity of a person standing on the surface of the Earth, relative to the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space and serves as the closest thing the universe has to a fixed reference frame, comes out at roughly 600 kilometers per second. That is approximately 1.3 million miles per hour. And that number, 1.3 million miles per hour, is the most honest answer to the question of how fast you're moving through the universe right now. 1.3 million miles per hour. I want to spend a little time making that number feel real, because numbers at this scale have a tendency to slide past the mind without leaving a mark. At 1.3 million miles per hour, you would circle the entire Earth in about 1.2 seconds. Not minutes, seconds. The circumference of the Earth is roughly 25,000 miles. At your current true speed through the universe, you would lap this planet in just over 1 second. In a single minute, you would travel 21 million miles. In an hour, 1.3 billion miles. The outer edge of the solar system, where the Sun's influence fades and interstellar space begins, is roughly 11 billion miles away. At your true cosmic speed, you would reach it in about 8.5 hours. Not the decades it took the Voyager spacecraft to get there, inching along at 35,000 miles per hour, 8.5 hours. The scale of speed we are discussing tonight is not the scale of anything human civilization has ever built or experienced in any direct way. Here is the thing most people never stop to consider. This speed, 1.3 million miles per hour, is not something you have ever not been moving at. You were born at this speed. Every person who has ever loved you has been moving at this speed. Every moment of joy or grief or boredom or wonder you have ever experienced happened at 1.3 million miles per hour. The first humans who painted animals on cave walls in the flickering light of fires, 1.3 million miles per hour. The builders of the Great Pyramids, 1.3 million miles per hour. Every philosopher who ever sat quietly and tried to understand the nature of existence, doing so while hurtling through the universe at 1.3 million miles per hour without the slightest awareness of it. This speed is not something that started recently. It is the permanent condition of every human life that has ever been lived on this planet. We have always been moving this fast. We will always be moving this fast. It is as fundamental to human existence as breathing, and almost no one ever thinks about it. There is something in that thought that I find deeply and quietly moving. Not in a way that produces urgency or anxiety, more in the way that a long view from a high place produces a kind of settling, a gentle release of the things you have been holding too tightly. All of the concerns of an ordinary day, the deadlines and the disappointments and the small frictions of a human life, they happen inside a vessel moving at 1.3 million miles per hour through a universe 13.8 billion years old. That does not make the concerns unimportant. A toothache is real whether or not the galaxy is moving. A broken heart hurts regardless of the galactic year. I'm not saying that cosmic scale erases human suffering. I am saying that it holds it. It frames it inside something so vast and so ancient and so continuously in motion that the individual moment, your moment, right now, tonight, becomes both smaller and more precious at the same time. Small because of the scale, precious because of the improbability. I want to give you one more way to feel this speed, because I think it is the most human and the most affecting of all the ways I know. The light from the sun takes 8 minutes to travel from the sun's surface to your eyes when you look at it. That means when you see the sun, you are seeing it as it was 8 minutes ago. The light from the nearest star beyond our sun, Proxima Centauri, takes 4.2 years to reach us. When you look at it in the night sky, you're seeing light that left it 4 years ago. The stars you see on a clear night are not where they appear to be. They are ghosts of positions, light that has been travelling for years and decades and centuries before it arrived at your eyes. And meanwhile, during all those years that the light was travelling, you were moving. At 1.3 million miles per hour in the time it takes light to travel from Proxima Centauri to Earth, you personally, carried by the Earth and the Sun and the Milky Way, have moved approximately 48 trillion miles through space. The light came to find you, and by the time it arrived, you were 48 trillion miles from where you were when it left. The universe is not static and you're not still. Both things are in motion, always, reaching for each other across distances that change every second. So let that be the image you carry with you as we continue tonight. 1.3 million miles per hour. You, right now, in the quiet of this night, moving through the universe at a speed that dwarfs everything human hands have ever built. Moving through the ancient dark, carried by a planet orbiting a star, orbiting a galaxy, falling towards something vast and half-hidden. Moving, always moving, in a universe that has never once been still. And feeling, as you lie here breathing slowly in the dark, nothing at all. 1.3 million miles per hour. We have arrived at that number together, slowly and carefully, and I hope it is sitting with you now as something felt rather than just understood. You're moving at 1.3 million miles per hour through the universe, right now, tonight, in the quiet of wherever you are lying. It is an astonishing speed. It is faster than anything human beings have ever deliberately built or launched. The fastest spacecraft ever created, the Parker Solar Probe at its closest approach to the Sun, reaches speeds of around 430,000 miles per hour. Our cosmic motion, the combined velocity of all those nested layers, is roughly 3 times faster than that. And yet, in the context of what I want to tell you in this chapter, 1.3 million miles per hour is not fast at all. It is, in fact, barely a whisper compared to the only speed the universe has ever declared truly fundamental. Tonight we need to talk about the speed of light, because light is not just fast, it is the wall, it is the ceiling, it is the hard, absolute, non-negotiable limit that the universe has placed on motion, and understanding it changes everything about how you understand the journey we have been on. Light travels at approximately 670 million miles per hour. 670 million. Our current cosmic speed of 1.3 million miles per hour represents roughly 0.2% of the speed of light. Not 2%, 0.2%, 1/5 of 1%. We are moving at a speed that sounds enormous by any human standard, and it is still so far below the speed of light that it barely registers on the scale. To put it in physical terms, if the speed of light were represented by the length of a football field, our current cosmic velocity would be about 8 inches from one end zone. We have barely left the starting line. The universe has given motion a ceiling so high that our most impressive speeds, including the one at which the galaxy is currently carrying you through space, are invisible against it. Where does this limit come from? Why can nothing travel faster than light? This is one of those questions that feels like it should have a simple answer and does not, at least not one that fits neatly into everyday intuition. The deepest answer physics can currently give is that the speed of light is not really a property of light specifically, it is a property of space and time themselves. It is the speed at which cause and effect can propagate through the universe. It is the rate at which information, any information, whether carried by light or by gravitational waves or by any other physical process, can travel from one place to another. Light happens to travel at this maximum speed because it is massless. Any particle with no mass travels at the universal speed limit by necessity. But the limit itself belongs to the universe, not to light. We call it the speed of light because light was the first thing we measured travelling at that speed. A more precise name might be the speed of causality. Now here is where the story gets strange in a way that I want you to follow slowly because it is worth following even at the edge of sleep. Einstein showed us in 1905 that the speed of light is not just a limit on how fast things can move, it is bound up with the very nature of time itself. The faster you move through space, the slower you move through time. This is not a metaphor, it is not a philosophical abstraction, it is a measured, confirmed, experimentally verified physical fact. We call it time dilation, and it has been detected in everything from atomic clocks on fast-moving aircraft to the decay rates of particles in particle accelerators. When you move faster through space, your experience of time genuinely slows down relative to someone who is moving more slowly. Time is not a fixed, universal river flowing at the same rate for everyone. It is flexible. It is personal. It depends on how fast you are moving. At the speeds we are discussing tonight, the time dilation effect is far too small to notice or measure in daily life. At 1.3 million miles per hour, 0.2% of the speed of light, the difference in the passage of time between you and a hypothetical stationary observer is completely negligible, a fraction of a second over an entire human lifetime. But the principle is real. You are moving, and therefore time is passing for you at a rate that is very slightly, almost immeasurably, different from what it would be if you were truly at rest. And as you approach the speed of light, that difference grows enormous. At 90% of the speed of light, time slows to roughly half the rate experienced by a stationary observer. At 99%, it slows to about 1/7. At 99.9% to about 1/22. The closer you get to the speed of light, the more time itself compresses, until at the speed of light itself, for a massless particle like a photon, time does not pass at all. A photon of light that left a distant star millions of years ago and arrived at your eye tonight experienced zero time in transit. From the photon's perspective, if it could have a perspective, it was emitted and absorbed in the same instant, regardless of the millions of light years between those two events. There is something in that idea that I find quietly staggering. Light does not age. It cannot age because it travels at the speed that freezes time entirely. Every photon that has ever existed, from the first light released after the Big Bang to the photon that strikes your retina when you glance at a candle flame tonight, has experienced the entirety of its journey as instantaneous. The universe is billions of years old, but light itself has experienced none of those years. Only the things that move below the speed of light, the stars, the galaxies, the planets, the people lying awake in the dark thinking about all of this, only they experience time. Only they age. Only they accumulate a past and anticipate a future. In a universe where light is ageless, the fact that we experience time at all, that we have a tonight and a yesterday and a tomorrow, is a consequence of being exactly as slow as we are. So here is the full picture, as completely as I can hold it for you tonight. You're moving at 1.3 million miles per hour through the universe. That is fast beyond any ordinary human reference, and it is 0.2% of the speed that the universe has declared its absolute limit. We are slow travellers on a fast road, in a cosmos where the fastest thing possible has no experience of time at all. We are the ones who age. We are the ones who feel the night pass and the hours accumulate and the years accrue into something called a life. And that is not a limitation to mourn, it is the thing that makes tonight possible. The slowness is the experience. The being below the speed of light is the whole of what it means to be alive in time. The wall we cannot break is the same wall that makes the journey worth taking. The discovery of the expanding universe is one of the great stories of 20th century science, and it begins with a name you may know, Edwin Hubble. In the 1920s, Hubble was working at the Mount Wilson Observatory in California, using what was then the most powerful telescope in the world, and he was studying faint smudges of light in the night sky that many astronomers still believed were clouds of gas within our own galaxy. What Hubble demonstrated by measuring the distances to these objects with a particular type of pulsating star used as a cosmic distance marker was that they were not nearby gas clouds at all. They were entire galaxies, each one containing hundreds of billions of stars, each one vastly far beyond the edges of the Milky Way. The universe was not our galaxy. Our galaxy was one small island in a cosmos filled with hundreds of billions of others. That alone would have been enough to secure Hubble's place in the history of science. But then he looked at something else. He looked at how those galaxies were moving. What Hubble found, building on earlier work by the astronomer Vesto Slipher, was that almost every galaxy he could measure was moving away from us. Not just a few, not just the distant ones. Almost all of them, in almost every direction, were receding, and the further away a galaxy was, the faster it was receding. This relationship, now called Hubble's law, carries an extraordinary implication that Hubble himself was initially cautious about stating directly, but that his contemporaries, including Albert Einstein and the Belgian priest and physicist Georges Lemaitre, had already begun to work out theoretically. If every galaxy is moving away from every other galaxy, and the recession speed is proportional to the distance, then the universe is not static. It is expanding. And if it is expanding now, then it was smaller in the past. Much smaller. Work backward far enough, and you arrive at a moment when all the matter and energy in the observable universe was compressed into an inconceivably small and hot and dense state. A beginning. What we now call the Big Bang. But here is the part of the expansion story that I want you to hold on to tonight. The part that connects most directly to our journey. When distant galaxies recede from us, they are not, in most cases, moving through space away from us the way a car drives away down a road. They are being carried away by the expansion of the space between us and them. It is a subtle but crucial distinction. Imagine drawing dots on the surface of a balloon with a marker and then inflating the balloon. The dots are not moving across the surface of the balloon. They are staying in the same place on the rubber, but the rubber is stretching, and so the distance between every pair of dots increases. Each dot sees all the others moving away from it, not because any dot moved, but because the surface between them grew. That is the expanding universe. The galaxies are the dots, space is the balloon, and the balloon has been inflating since the Big Bang, 13.8 billion years ago, without stopping, without slowing down, and in fact, as we discovered in 1998, accelerating. The acceleration is where the story becomes genuinely terrifying, in that slow, quiet, permanent way that the deepest cosmological facts often are. In 1998, two independent teams of astronomers studying distant exploding stars called supernovae made a discovery that shocked the entire cosmological community. They expected to find that the expansion of the universe was slowing down. Gravity pulls matter together, and the combined gravitational pull of all the matter in the universe should, by all reasonable expectation, be putting a brake on the expansion over time. What they found instead was the opposite. The expansion is speeding up. The universe is not just growing, it is growing faster every year. Some unknown form of energy, now called dark energy, is embedded in the fabric of space itself, and it is pushing space to expand at an accelerating rate. Whatever dark energy is, it outweighs all the matter in the universe combined, comprising roughly 68% of the total energy content of the cosmos. We do not know what it is. We can measure its effects with precision. Its nature remains one of the deepest unsolved problems in all of physics. Now here is the consequence of this acceleration that I find the most genuinely sobering of all the things we have discussed tonight. Because space is expanding, and that expansion is accelerating, there is a distance beyond which the space between us and a given galaxy is growing faster than light can cross it. This is not a violation of the rule that nothing can travel faster than light, because the galaxies are not moving through space. Space itself is expanding between us, and there is no speed limit on how fast space can expand. Beyond a certain distance, roughly 46 billion light-years in every direction, galaxies are being carried away from us faster than light speed. Their light will never reach us. No signal, no information, no evidence of their existence will ever arrive at our location. They are beyond our cosmic horizon forever, not just very far away, permanently, absolutely, irrevocably unreachable, and because the expansion is accelerating, that horizon is shrinking over cosmic time. Galaxies that are currently just inside our observable reach will eventually be carried over the horizon. The observable universe is not staying the same size. It is slowly, inexorably losing galaxies to the dark. Right now, tonight, there are an estimated 2 trillion galaxies within our observable universe. 2 trillion islands of stars, each containing hundreds of billions of suns, all of them in principle detectable if we built telescopes large enough and waited long enough for their light to arrive. But the expansion is carrying the furthest ones away faster than their light can reach us, and in the very deep future, hundreds of billions of years from now, the Milky Way and its immediate gravitational companions will be the only structures visible in an otherwise dark and empty sky. All evidence of the larger universe, all those trillions of galaxies, will have been swept over the horizon by the expanding dark. Future inhabitants of the Milky Way, if any exist, will look out at an empty sky and have no way of knowing that a universe of 2 trillion galaxies once shone all around them. The expansion will have hidden it all. We live in a privileged moment, cosmologically speaking. The evidence is still here. The light from 2 trillion galaxies is still arriving. Tonight, if you stepped outside and looked up, that light would be falling on your face. Moving through it right now at 1.3 million miles per hour on a rock in a spiral galaxy in a supercluster falling toward the Great Attractor, inside an expanding universe that is gently, patiently erasing itself into the dark. The observable universe is roughly 93 billion light-years across. This number surprises most people who encounter it for the first time, because the universe is only 13.8 billion years old. If the universe has only existed for 13.8 billion years, how can we see things 93 billion light-years away? Surely the light from something 93 billion light-years distant would have taken 93 billion years to reach us, which is longer than the universe has existed. The resolution to this apparent paradox is the expansion we discussed in the last chapter. The objects we are seeing at the edge of the observable universe were much closer to us when they emitted the light we are now receiving. But in the billions of years that light has been travelling toward us, the expansion of space has carried those objects much further away. When you account for the expansion, the current distance to the objects whose ancient light is just now reaching us works out to about 46 billion light-years in any direction, giving the observable universe a diameter of roughly 93 billion light-years. The light is old. The objects it came from are now much further away than the distance the light travelled. The cosmic microwave background sits at the very edge of what we can see. This is the faint ancient light released about 380,000 years after the Big Bang, when the universe had cooled enough for hydrogen atoms to form, and the cosmos went from being a hot, opaque plasma to a transparent gas through which light could travel freely for the first time. Before that moment, the universe was essentially opaque, like the interior of a star, too hot and dense for photons to travel more than a tiny distance before being absorbed. The moment it became transparent, light flooded outward in all directions. That light has been travelling ever since, stretched by the expansion of the universe from visible light into the microwave range of the spectrum. It now fills the sky in every direction as an almost perfectly uniform background glow, too faint and too cold for human eyes to detect, but precisely measurable with the right instruments. When we look at the cosmic microwave background, we are looking at the oldest light in the universe. We are seeing, in a sense, the moment the universe became visible. Behind it, before it, is a wall of opacity that we cannot see through. It is the ultimate limit of our direct observational reach. But here is the question that haunts cosmology in the way that deep questions always do, arriving quietly and refusing to leave. What lies beyond the observable universe? Not beyond in the sense of behind the cosmic microwave background, which is still within our universe in the ordinary sense, beyond in the sense of outside our observable horizon entirely. What exists in the regions of space whose light has never reached us and never will? The honest answer is that we do not know. We cannot know. Not because we lack the right telescope or the right theory, but because information from those regions has had no causal connection with us. Nothing that happened there has ever affected anything here. They are beyond the reach of any observation, any measurement, any detection. They are permanently, structurally outside our knowledge. What most cosmologists believe, based on our best current models of the early universe and the process called cosmic inflation, is that the universe beyond our observable horizon is simply more of the same. More space, more galaxies, more stars and planets, following the same physical laws, distributed in roughly the same statistical pattern we see within our observable bubble. The universe is almost certainly vastly larger than what we can see. Some models suggest it could be thousands of times larger. Others suggest it could be effectively infinite. The inflationary models that best explain the large-scale structure of the observable universe generally predict that inflation produced a total volume of space that is almost unimaginably larger than the region we can observe. We are like a single tide pool trying to infer the size of the ocean. The pool is real. The water in it obeys the same physics as all other water, but the ocean is beyond any measurement the pool could ever make. There is a version of this idea that is even more extreme, and I want to mention it gently because it sits at the frontier between established cosmology and speculative theory. Some physicists have proposed that in a sufficiently large or infinite universe, the same initial conditions that produced our observable region, with its particular arrangement of matter and its particular physical constants, would be reproduced elsewhere, simply by chance, in regions so distant that they are entirely beyond our horizon. In a universe large enough or infinite enough, everything that can happen does happen, somewhere, infinitely many times. This idea, sometimes called the Level 1 multiverse, does not require any exotic physics. It requires only a very large universe and the straightforward application of probability. Whether it is true, and whether it is even meaningful to ask whether it is true given that it is in principle unverifiable, are questions that remain deeply contested. But the idea that you, reading these words, lying here in the dark, might have counterparts in regions of the universe forever beyond the reach of any light or signal, is one of those thoughts that sits at the precise intersection of physics and philosophy, and refuses to be comfortable in either. I want to close this chapter with something simpler, and closer, and more immediate. The observable universe, vast as it is, 93 billion light-years across, 2 trillion galaxies, an estimated 1 septillion stars, is your universe. It is the universe that is in principle knowable to you and to every other conscious being in the Milky Way. It is the universe whose light is falling on this planet right now, whose ancient photons are passing through the walls of the room you are in, whose cosmic microwave background is a faint and universal warmth that surrounds you on every side. You're inside this observable universe, not at its centre, because it has no centre that belongs to any one place, but not at its edge either. You're somewhere in the middle of an immense, ancient, expanding bubble of causally connected space-time, moving through it at 1.3 million miles per hour, awake to it for a brief and improbable moment, on a small and beautiful planet orbiting an ordinary star in a galaxy that is one of 2 trillion. The darkness beyond the horizon is real, but the light inside it is staggering, and tonight, all of it is yours. Let us begin with something called the arrow of time. You have experienced this every moment of your life without ever needing a name for it. The past is fixed. The future is open. Time flows in one direction, from what was to what is to what will be, and you cannot reverse it. You remember yesterday but not tomorrow. A broken cup does not reassemble itself. A candle flame does not unburn the wax. Heat flows from hot objects to cold ones, and not the other way around unless you add energy to force it. These are all expressions of the same underlying reality, the arrow of time pointing inexorably in one direction. But here is the strange thing that physicists have known for over a century, and that still unsettles many of them when they think about it carefully. The fundamental laws of physics, the equations that govern the behavior of particles, and forces at the most basic level, are almost entirely symmetric in time. Run most of them backward and they still work. A movie of 2 billiard balls colliding looks equally valid whether you play it forward or backward. The laws of quantum mechanics and electromagnetism and gravity do not, at their core, prefer one direction of time over the other, and yet time has a direction. Obviously, unmistakably. The arrow is real, so where does it come from? The answer, as best as physicists can currently determine, comes from entropy. Entropy is a measure of disorder, of the number of possible arrangements a system can be in. The second law of thermodynamics states that in any isolated system, entropy tends to increase over time. Things tend toward disorder. Heat spreads out, structures break down, information disperses, and the reason this process has a direction, the reason entropy increases rather than decreases, is ultimately rooted in the initial conditions of the universe. The Big Bang produced a universe in an extraordinarily low entropy state, extraordinarily ordered in a specific thermodynamic sense. And ever since that moment, The universe has been evolving from that initial low entropy state toward higher and higher entropy, driven by the simple statistical reality that there are vastly more disordered states than ordered ones, and so any random evolution of a system is overwhelmingly likely to move toward disorder. The arrow of time is the arrow of entropy, and the arrow of entropy points away from the Big Bang. Time flows in the direction it does because the universe started in an unusually ordered state and has been unwinding ever since. Now here is the connection to motion, and I want you to feel this rather than just follow it. Motion and time are not separate things running in parallel. They are aspects of the same underlying fabric that Einstein called space-time. In the geometry of space-time, every object is always moving, always at the speed of light. Not through space, but through the combined dimensions of space and time together. If you are sitting perfectly still in space, all of your motion through space-time is directed through time. You're moving through time at the maximum rate. But if you begin moving through space, some of your space-time velocity shifts from the time dimension into the spatial dimensions. This is why moving clocks tick slower. It is not metaphorical. The faster you move through space, the less of your space-time motion is directed through time, and so time passes more slowly for you. At the speed of light, as we discussed earlier, all motion is through space, and none is through time. Photons do not age. They have traded all their temporal motion for spatial motion, and in doing so they have exited the flow of time entirely. What this means, in the most personal and immediate sense, is that to exist in time, to have a past and a future and a present, to age, to remember, to anticipate, you must be moving below the speed of light. Time is not something that happens to you from outside. It is something you are made of, something woven into the geometry of your motion through space-time. Every second that passes for you is a second of motion through the time dimension of a four-dimensional universe. Every heartbeat, every breath, every moment of lying here in the dark listening to these words is a moment of traversal through space-time at the universal speed, with most of that speed directed through time rather than space. Your experience of duration, the feeling that tonight is passing, that you are moving from wakefulness towards sleep, that this moment will become a memory, all of that is the phenomenology of your motion through the time dimension. You are not just moving through space at 1.3 million miles per hour, you are moving through time at the speed of light itself. And then there is the heat. The second law of thermodynamics, entropy and its arrow, connects motion to the ultimate fate of everything. All motion at the microscopic level is thermal. The atoms that make up your body are vibrating, colliding, transferring energy in the ceaseless chaotic dance that we measure as temperature. The stars are powered by nuclear processes that convert matter into energy, releasing that energy as light and heat into the surrounding space. The galaxies radiate. The cosmic microwave background carries the residual warmth of the Big Bang itself, still cooling after 13.8 billion years. All of this is entropy increasing. All of this is the universe moving from its initial low entropy state toward the eventual state that physicists call heat death. A future so distant it makes the current age of the universe look like the first microsecond of a very long day, in which all stars have burned out, all black holes have evaporated, all temperature differences have equalized, and the universe has reached a state of maximum entropy and minimum free energy, in which no further process of any kind is possible. Complete stillness, final and absolute and permanent. The only true stillness in the universe's history, and it lies at the very end of time. But tonight is not that night. Tonight the stars are burning, the galaxies are moving, the cosmic microwave background is still warm enough to measure, and you are here, a temporary and astonishing concentration of low entropy, a pocket of order in a universe trending toward disorder, conscious and breathing and moving through space-time at the speed of light, with most of that motion directed through time, experiencing the passage of an evening drifting towards sleep. The arrow of time is pointing forward, as it always has, as it always will until the last cold second of the universe's last cold era. And tonight, on this particular evening, the arrow is passing through you. You are inside it. You are made of it. Motion, time, entropy, consciousness. They are not separate things happening in parallel. They are one continuous unfolding, the same river seen from different banks. And you are not standing on the bank watching it pass. You are in the water, moving, always moving, carried by a current that began at the Big Bang and will not stop until the last star goes dark and the last black hole exhales its final quantum of radiation into a universe too cold and too empty to do anything with it. You are a traveller who never chose to leave. That is the simplest and most complete summary I can give of everything we have explored tonight. You did not decide to be born on a spinning planet. You did not apply for passage on a solar system orbiting a galactic core. You did not choose the galaxy that would carry you, or the supercluster that galaxy belongs to, or the direction of the gravitational flow that has been pulling everything you've ever been part of toward the great attractor since before the Earth existed. You arrived in the middle of a journey that was already billions of years old, aboard a vessel of staggering complexity and beauty, moving at speeds that your body was never equipped to feel, through a universe so vast that the portion of it you can observe in principle contains more stars than there are grains of sand on every beach and desert on Earth. You did not choose any of this, and yet here you are, inside it, part of it, moving with it at 1.3 million miles per hour through the ancient dark. I think about what it means to be a passenger on a journey you never chose, and I find that it is not a diminishment. It is not a statement about powerlessness or insignificance, though the scale certainly invites those feelings if you let it. It is something else, something closer to the feeling you get when you are carried somewhere beautiful, when someone else is driving, and you can let your eyes go soft and watch the landscape pass without the responsibility of navigation, and you arrive somewhere you could not have reached alone and would not have thought to go. The universe carried you here, to this night, to this moment of lying still while everything moves, to this particular configuration of matter and energy and consciousness that is you, awake in the dark, aware of the stars above the ceiling, aware of your own awareness. You did not plan this trip, but you are on it. And it is extraordinary. Every moment of your life has happened in motion. Every conversation you've ever had, every meal, every morning you woke up and looked at the light coming through the curtains and felt something you could not name but that belonged to being alive. All of it happened while the Earth was spinning at 1,000 miles per hour and carrying you around the Sun at 67,000, and sweeping through the galaxy at 514,000, and falling through intergalactic space at 1.3 million. Every grief you have survived happened at 1.3 million miles per hour. Every love you have felt happened at 1.3 million miles per hour. Every ordinary Tuesday, every extraordinary night, every moment of confusion, and every moment of sudden clarity happened aboard this vessel, moving through the cosmos at a speed that staggers the mind when you stop to actually look at it. The motion was always there, beneath every moment of your life, constant and invisible and immense. The universe was carrying you forward, and the stillness was always there too. That is the other thing I want you to hold. The stillness you feel right now, lying here in the dark with your breathing slow and your body at rest, that stillness is real. Not real in the sense of being physically accurate, we know by now that it is not, but real in the sense of being a genuine experience of a genuine feature of your situation. You're moving at 1.3 million miles per hour, and you're also genuinely, functionally, experientially still. Both things are true at the same time. The motion is real. The stillness is real. The universe is vast beyond any number that can hold it. And you are here, inside it, small and temporary and conscious, which is the most astonishing combination of properties in all of the cosmos that we know of. Vastness is easy. The universe is full of it. Consciousness is the rare thing, the improbable thing, the thing that required 4.5 billion years of planetary history and the right conditions and the slow accumulation of complexity to produce, and that has existed, as far as we know, for only a brief and fragile moment in the timeline of a 13.8 billion-year-old universe. We are the universe noticing itself. I have said versions of that phrase before, and I return to it again now not because it is a slogan, but because I believe it is the most precise description available for what you are and what tonight is. The matter that makes up your body was forged in the cores of stars that died before the sun existed. The carbon in your cells, the oxygen in your lungs, the iron in your blood, all of it was produced in stellar interiors and scattered by stellar explosions across the galaxy over billions of years before gravity and chemistry assembled it into you. You are made of the universe, literally, materially, without metaphor. And the part of the universe that is you has developed the capacity to look at the rest of the universe and wonder about it, to feel something in the presence of its scale, to lie awake at night and think about motion and time and the edges of what can be known. That capacity, the capacity for wonder, for awareness, for the particular feeling that comes when a true and enormous thing lands in your mind and changes the shape of how you see everything else, that is the rarest and most precious thing in all the 93 billion light-years of observable space. Nothing else we have found does it. Only this. Only you and the others like you, brief and bright and moving through the dark at 1.3 million miles per hour. So let the Earth spin beneath you tonight. Let the solar system carry you on its great arc around a galaxy that is older than imagination. Let the Milky Way fall toward the great attractor through intergalactic space, as it has been doing since long before any living thing existed on this planet. Let the universe expand around you in all directions, carrying the light of 2 trillion galaxies outward into a darkness that is also, in some sense, you. You do not need to hold any of it. You do not need to understand it completely, or resolve the vertigo it produces, or make peace with every number we have named tonight. You only need to be here, and you are. Moving, always moving, through a universe that made you from its oldest materials and set you in motion before you drew your first breath, and that will carry you forward, tonight and every night, through the ancient and unending dark. Thank you for travelling with me. Thank you for staying with me all the way to the edge and back. If this journey meant something to you, if it gave you even one moment of that particular feeling that comes from looking at the real scale of things, please take a second to like or subscribe. It helps more curious minds find their way here, into the dark, where the best questions live. The next time you step outside on a clear night and look up at the stars, remember that you are not standing still beneath them. You are moving toward them, and through them, and among them at 1.3 million miles per hour, on a journey that began before you were born and will continue long after tonight. Sleep well, keep looking up, good night.